So we're getting ready for the sequences and binomial theorem test. Let's start with binomial theorem. Let's say I give you this one, x minus 4 to the fifth, and I would like you to find all 6 terms of that. Now, you could do a, you could do a, one of those triangles, the Pascal's triangle. Everybody start by making a Pascal's triangle. That's a super simple, like you start with a 1, and then you get 2 1s, then 1, 2, 1. You know which triangle I'm talking about? Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Keep going for a while, and that'll help you to find in these 6 terms. You will need 6 coefficients for the front. All right, pause for a second. Okay, Zodi, can you tell me the appropriate line from the triangle that I should use to put the numbers here, here, here?
You should use line number 5.
Okay, so what does it start with? I'm pretty sure it's a 1.
Yeah, starts with 1, then 5, then a 10, then another 10, and then 5 and 1.
Excellent. Okay. And this is why we usually, if we're going to say only do like the third term or whatever, that we never use the first or the second, because this one always will be a 1, and this will always be the power that is on top. And this will always be a 1, and this is always the power that's on top. So you see how there's really only a few to figure out? All right. So let's go to Olivia. Can you tell me how to do the x's?
You do x to the fifth, and then x to the fourth, x to the third, x to the second, x to the third, then x to the 0.
And we can even leave off the x to the 0 because it's just 1. And then let's go with a volunteer who's willing to tell me what to do with the negative 4s. L?
So I put in front of the second term.
This one would be to the 0, right? So then negative 4 to the?
Just negative 4.
Oh, to the first.
Yeah.
Okay, and then negative 4 to the
Second term.
second, negative 4 to the third, negative 4 to the fourth, and negative 4 to the fifth. Okay, numbers get kind of big there at the end. If you haven't already, grab a calculator, because calculators will be allowed in this next test, and this would be a moment where, for instance, you could use a calc to clean up your final answers. This first one's easy because it's just x to the fifth, and the other stuff they're just 1s. So this one would be x to the fifth. What's the next term? Gabby, what'd you get for the second term?
Negative 20x to the fourth.
Negative 20, x to the fourth. Good. How about the third term? Let's go with Jackson.
I got 160x to the third.
Positive 160, x to the third. Correct. Jackson, you do the next one also.
And then minus 640x squared.
That sounds right. Can anybody verify negative 640 x squared? A lot of people. Good. And the second to last term, Zodi.
The second to last term would be x to the fourth, which would be, so 4.
It's actually x to the 1, but negative 4 to the fourth.
Sorry, I meant negative 4 to the fourth.
Okay. And you're obviously typing it in on the calculator. That's totally fine. It'll be positive something, and then don't forget the times by 5.
It is positive 1,280.
1280?
Yeah.
All right, I messed up my 1280. All right. And then that's x to the 1. And then Zodi, the very last one.
And the last one is 4 to the fifth, which would be 1,000.
How about just read me the digits? It's hard to put the commas in your head, I know. Just read me the digits you got.
1024.
Feels too small, but it could be right. Raise your hand if you had 1024. Okay, my bad.
Yeah, it's small because of the one in front.
Yeah, there's no like lead, like these numbers, and this is just a 1, so you're, good point.
Because like, well, you multiply it by 4, you're also dividing it by 5, so it's all loss.
All right. There's 6 terms. What if they had said, just find me the third term? Well, duh, that'd be this one. What if they said, find me the term that has an x squared and tell me its coefficient? Would you please highlight it on your iPad? The term with the x squared, highlight its coefficient. Did you know that that terminology meant that is the coefficient of the term that has x squared in it? Okay, and then they also use 2 fancy names for this other thing. Let's see if I give you one of the fancy names, if you can give me the other. The term independent of x. Cal, you know which one I'm talking about?
Negative 1024.
Correct. And can anybody give me another name for it besides the term independent of x? Sasha?
Constant.
The constant. Very good. Okay. Any more questions on those? They can get more complicated, of course. Like, what if this had been x over 2? Just, you would have carried through an x over 2 everywhere there had been an x. So this blue x to the 5th would have been x over 2 to the 5th, like this. So then the 2 would have been to the 5th also, if we had put a x over 2 in the problem, for example. Okay, all right. That's binomial expansion in a nutshell. Now let's talk about all the other sequences and series stuff. Here's a nice, simple one if you know what it means. Would you find for me the first 3 terms of this? By doing that, you'll be able to pretty quickly tell what the R or D is. And you can't tell until you find the first 3 terms. So find the first 3 terms, then you'll be able to figure out what the R or the D is. Pausing.
Negative 1, 1, 3.
Did you catch on to whether what's happening?
Plus 2.
Adding 2 each time? Good. Now that we know that, we can turn this into a different problem. The actual problem. The actual problem isn't to find just a couple terms. You're supposed to know what this means. What does that thing mean? Neil, what does it mean? Okay. You can't just list the terms, the first 4 terms. The summation. You're actually supposed to add them all up. Now, is there a formula that you could have done it with? I know it's like, this is so easy, but practice the formula. It starts with S, not sub infinity. In this case, it's S of 4 because it's the first 4 terms. And then the starting term was negative 1. And then you do something to that. You should know this formula for S sub anything for an arithmetic. Write out the formula, stick in the numbers, and then you should be able to find the 4th term by yourself, just like into your head. And then add them all up and see if it matches what this adds up to. Okay, so use the sum formula and match that against your reality of what these first 4 terms should add up to.
Sum is 8.
And you could have done that by just finding this last number, which you'd have put in a 4, and you get a 5 here. And then just 5 plus 3 is 8, and these 2 cancel each other out, so that would have been easy. Or, tell me how you could do it with the formula.
So I use the formula, so it's S of 4 equals 2 times
Wait a minute, where'd you get 2?
n over 2, so 4 over 2.
Oh, we're going to use that formula that's got an n over 2 here. And then the first one,
Negative 1.
and then another
Negative 1.
negative 1, and then
Plus n minus 1, so 4 minus 1, which is 3, times the common difference, 2.
times the common difference of 2. Cool. And n was actually 4, so we should put that here too. So it's 2 times parentheses negative 2 plus 3 times 2. So then this part becomes 4 times 2 makes 8. And that adds up to 8. Cool. All right, next, a little more challenging kind. That is an arithmetic sequence. The first and the second term of an arithmetic. Would you please figure out what x has to be? Well, if you can write out one equation with this, it's got one variable, you'll be able to solve it. One equation, one variable, that's something you can solve. If you had two variables, you'd need two equations. All right, pausing. All right, so if it's arithmetic, you know that this one plus some mystery number had to equal that one, right? Did you guys agree with that? All right, so if I said 2x plus 4 plus some mystery number, I got to call that like D for common difference, had to equal 10. I hope you didn't struggle for too long because you can't solve that. Why? I did say it in the problem when I told you the problem. I said as long as we have an equation with only one variable, we can solve it. If we have two variables, then you need what? You need two equations. All right. Could anybody have solved that? Did anybody think they solved it? All right. Okay, so then what could we do? What could we add to it that we'd be able to use to solve this equation? Well, we got one equation that's got two variables. This is a good equation. I'll write it again with a different pen style to make it easier to read maybe. Okay, what if we had another equation, another term? What if I told you the next term in here, and I said this other equation for the third term is I want it to work out nice, so I'm going to pause for a second to make it work nice. Okay, I figured it out. If the third term is this, it'll all work out really nice. Would you please, the whole mystery of this is what are they adding each time? You know, what is the D? So our first equation was already done and it's here. Make another equation and then solve the system of equations. So I added this term right here. And now you should be able to write a system of two equations and then solve it for D. You'll be able to tell me the common difference. Pause for a second while you try that. Okay, so the other equation, let's go with Neil. What equation did you get for this one?
I got D equals 3x times 4.
Okay, that's, nope. Not saying it's necessarily wrong, but let's use the same format we did last time, which is you start out with a 10, and then you have to do something with D, and then you get the other term. So you'd take 10, you would add D, and you would get 3x plus 6. Now after you solve it down some, sure, you could get lots of different ways you could say that. Like you could subtract 10 right now, and then you'd have D equals this, and all right. Now you got two equations. Now you have to solve them and use a system. It wouldn't be a bad idea to solve for D right there and say it's 3x taking away 10, minus 4, and then put the 3x minus 4 right there. And now I've got 2x plus 4 plus the d, which was 3x minus 4, equals 10. And let's save a bunch of time. 1, 2, skip a few. What was x equal to? Gabby,
X is equal to 2.
raise your hand if you had. X equals 2. Okay, good. All right, now, this would be really stretching it, but do you get if this is the first term? And if we now know that x equals 2, then you could have figured out the r. Not the r, sorry, the d. If x equals 2, would you please figure out d equals what? And it won't take you too long to go, well, if this is 2, and you have to add something to it, it'd be 4 plus 4 is 8. 8 turns into a 10, it must be add 2. So d equals 2. So d equals 2 and x equals 2. Cool. Then tell me this. If this is the third term and d equals 2, how could we have solved it using a different equation? If this is the third term and d equals 2, there's another equation we could have used to solve it. I'm going to pause for a second and see if you can set up that equation. Hint, it's one of the equations off the board. We'll see if you can figure out which one. So, this is not the one where they sum up, it's the one where you'd find a term. So it's u sub n is equal to, and this one is, starts with a 0 plus n minus 1 times d. And I know lots of those things. I know the d, which is 2, so I could put that there. I know the n is the third term, so I could put a 3 there. And the starting term, I even know that. The starting term was 2x plus 4, and I could put that there. Okay, and that final term, the third term, is this, so that 3x plus 6 could go here. And that is some heavy-duty algebra. It's just a heavy-duty setup. Now it'd actually be an easy equation to solve. 2x plus 4, and 3 minus 1 is 2d. Oh wait, d is 2. Sorry. So this was all the first term, and then I have a plus 2, 3 minus 1 is 2, times d, which is also 2. There we go. And look at that, it only has x in it, and you'd be able to solve for x that way. Okay, enough about setting up equations. Let's see if you can just tell me the first 3 terms of this infinite sequence. First, let's just make it the first 2 terms. And then tell me S sub infinity. Pause for a second. You figure this out, or not. So if we stick in 1 and 2 to find those first 2 terms, what did you get for your first 2 terms? So 4 to the 1, which is 4, and then 4 to the 2, which is 16. So those are the first 2 terms. Good. Do you get the feeling that you're just going to keep multiplying by 4? So then can you tell that this is geometric? And if it's geometric, what are the rules about adding things up to infinity? A0 over 1 minus r. Wrong. Why? That's the only infinity formula we have. Why is it not going to work? Neil. They have to be getting smaller, which means r has to be what? Less than 1. Is our r less than 1? No. Our r is a 4, which is clearly not less than 1. So if you tried to use this, it would give you a nonsense answer. the starting term is 4, over 1 minus 4, which would be 4 over negative 3, and do you really think that they all add up to negative 4/3? No, that just doesn't work. So the point is, this is a dangerous formula, because you can stick numbers in it and you can think you have found the answer, but that doesn't make any sense. If you actually added up all these numbers, they just get bigger and bigger and bigger, and they're gonna not converge. They're going to, if you don't converge, you what? If terms are not saying, dang it, I just said it. If they're not converging, they're diverging, okay? So this only works if the terms are converging, which is like, for example, if you graphed a bunch of terms that were converging, it'd be like this. They're getting really, really, really close to 0. They keep getting closer and closer and closer to 0, for example. Okay. All right, let's see. We've done binomial. Some of the binomial ones can be tough. All right, here's one. 2 times something times something times something again, and you get to 800. This was geometric because I kept on saying times something. That's enough info for you to know this and this. Figure out the two terms in the middle. Hint, use the right formula, stick in the right numbers. I didn't tell you I didn't tell you R, but you can figure it out. Use the formula. Stick in what you know. Pausing. Okay, so this one's got a whole bunch of different ways you could do it, but I think the easiest way, you stick it into the right formula. So I got a geometric formula that doesn't add up terms. That must be this one. That's a sub n equals a sub 0 times r to the n minus 1. And I know a lot of those things. I know a sub n is 800, so I put an 800 right here. And a sub 0 is 2. And r, I don't know that, so I put r. N minus 1, well, this is the fourth term, so I go 4 minus 1, and 4 minus 1 is 3. And if you can solve that, you've got your answer. Okay, so you do have a calculator. Hopefully you can use your calculator and go 800 divided by 2 is 400, and then the cube root of 400. If you don't remember how to do that, I'll remind you. You put it to a power of, anybody know? 1/3. If you can't do 400 to the 1/3 power, you would have bombed that question. So see if you can do it on your calculator. If you can't figure it out, put a parenthesis around the 1/3, and I bet it'll work better. Okay. And last but not least, there is a Schoology quiz. And it is assigned for homework tonight. And I'd like you to start it right now. It's got the answers after your first try. And if you're willing to do it for a second try, you get the higher of the two scores. Okay? So take it seriously like a test. It'll grade it for you. It'll tell you the right answers. And that's your homework for tonight. There's also a second thing you can do for homework tonight, which is, don't put your stuff away. We're not leaving yet. It's very soon, but just open the Schoology quiz, please, right now. So I want to see everybody start the Schoology quiz. That way I know you know where it is, and I can tell if you started or not. Okay, so the Schoology quiz, plus there's another thing that's not required. But some kids are nervous because it's their last test, and they don't have to deal with a retake. So I've got extra problems there for you. Okay, Schoology quiz required. The other thing, optional. And that's all I got for you for today.